Now, if you guys remember, the positive and the negative, they need to balance out with one another. So if we take a look at this, do we have more positive energy or do we have more negative energy? Yeah, we got more negative energy, right? Because it's -3. And so what we have to do is we need to balance this out so that we can have the same amount of positive and negative energy. So if you guys look at AG is +1. So how many total AGs do I need in order to balance this one out? How many total do I need? Yeah, you need 3. Because if you have 3 different AGs, they add up to a total of +1, 2, 3, and it can balance out the P right here. Okay? So all we got to do for the equation is just put a 3 in the front. That way it shows us we have 3 individual AGs. Okay, and that'll balance out the P, and then they're just going to stick together because remember, opposites attract, right? Positive and negatives, they combine to make an ionic compound. So we're going to create the molecule Ag3P, and that's it. Okay. So for your final answer, and I will guarantee you right now that this kind of problem will be on your exam on October 6th. Okay, you're gonna have to give me what is inside of this box. Because you need 3 total AGs to balance out the P. So let me draw it out just to kind of help you guys visualize. But if there's a 3 in the front, it means that there are 3 individual AGs kind of just hanging out like this. Okay. And then for P, you got a P3 minus. But when you write them together like this, that means they have combined together to create AG3. And so there's 3 of them combined, and it's combined with the P right here. So this is one molecule. These are all separate ions kind of just floating around. Okay. So yeah, we'll practice more today. This is like the last new thing before the exam. So today we're adding one little thing on top of this. So it's not anything different. It's just this concept. So you'll have some time to practice it out. Okay. Any other questions about this? Alrighty, let's go to the counting. So hopefully the counting is not too bad now. The first element that we have is potassium, K. How many Ks do we have? Yeah, 2. The number behind it tells you how many you got. So you got 2 Ks. God bless you. Okay, the next one is Ba. How many Bas do we have? Yeah, we got 1 because there's no number. Now, if you guys notice, SO4 is inside of parentheses with the 2 on the outside, which means we got to multiply everything on the inside by the number on the outside. So that means we're going to have a total of 2 sulfurs, and we're going to have a total of 8 oxygens. Okay. Alrighty. Any questions about, yeah. This right here? I'm not going to give you a problem that looks like this. This is just so you guys know how to count these molecules, because I noticed in the previous assignment, a lot of people had trouble like breaking down the molecules and seeing how many elements were in there. So I kind of just wanted to review it. Okay. But yeah, most of the points from your test, I'll just let you guys know, are going to be number 1 type of problems. Yeah. Yes. Alrighty, so let's move on. So make sure you guys titled your lecture notes polyatomic ions, because that's what we're going to be talking about. So we've been talking about ions, right? How it's positive and negative atoms. Now we're going to be talking about something called polyatomic ions. Now the word is a lot scarier than it is, but what we've been looking at so far, and you guys do not need to write this down, we've been looking at ions that are just one atom, right? Just one thing on the periodic table. However, now we're going to be learning about something called polyatomic ions. And this part you do want to write down. Just the highlighted part. Don't copy this table. Polyatomic ions are molecules that have a charge. It's groups of molecules. When you put them in together, they form a charge, but they stay together as a group. Okay, so make sure you're writing this part down. Polyatomic ions are molecules with a charge. And what I'm going to do now is I'm going to pass out a periodic table with a list of polyatomic ions. You guys can keep these, so I'll just pass them out right now. Take one out. Okay. So these are for you guys. I don't want it back. Yes. That word right there, polyatomic. All right, so if you guys take one, I'll pass it down where the stuff yet. Alrighty, guys. So let's take a look. My bad. At the handout that you guys just got. So on one side, you got a periodic table, which we're familiar with. We've been working with. But I want you guys to flip to the back side, because there's going to be a chart that looks like this. Everybody got that? Okay, so this is a list of polyatomic ions that we will be using in this class, and this is the first out of 4 you need to memorize. Okay. I'm just kidding. You guys don't need to memorize this. I'll provide this on the test for you guys. Okay, so you guys just need to know how to use this chart. And so I'm going to show you guys how we use it. So if you guys, let's take a look at ammonium. Okay. Ammonium is the name of a polyatomic ion, and we got the formula right here. So ammonium is a molecule, if you guys notice, NH4. And this NH4 has a positive charge. Okay. That's how you use it. If you look at phosphate, the molecule is PO4, but it has a 3- charge. Okay, so all we're doing now is just taking those individual ions. Remember how we've been working with like Na+, O2-. Instead of just looking at one element, we're looking at a molecule. The whole thing has a charge, and it sticks together, okay? So I'm going to show you guys how to write balance equations with that. So let's just go straight into our first practice problem. Okay, so this is exactly what we've been doing. We've been writing balanced equations, but this time we're going to be putting in one polyatomic in there, okay? So what we're going to do here is we're going to combine Ca2+, and we are going to combine that with nitrate, okay? Ca2+ and nitrate. All right, so Ca2+ is something that we already know, right? It's calcium. It's got a 2+ charge, but we don't know nitrate. And if you look on the periodic table, I'll let you guys know there's no nitrate. So what we're going to do is we're going to look at the polyatomic chart. So let's go to the chart and look for nitrate. So everybody look at your chart, look at nitrate. Okay, nitrate is NO3-. So all we're going to do is go back to our problem, and we're going to change this out for NO3-. Yeah, this is part of your notes. All practice problems are part of your notes. Okay, so just keep that in mind. If you guys see something that you don't see on a periodic table, just check the polyatomic chart. Usually it's because I'll write the name and it'll be a polyatomic. So far, so good? Okay. All right, and then so we got Ca2+, and we're combining that with NO3-. Okay, and then from here, it's basically the same thing we did last time, right? Do we have more positive energy or negative energy? We got more positive energy because remember, the charge is always on the top right. Okay, so we got +2 and we got -1. It doesn't matter if there's a 3 down here. The little number on the bottom doesn't have anything to do with the charge. It just tells you what the molecule is. So this is -1 and +2. So that means we have way too much positive energy, right? So that means we're going to balance that out by adding some more negative. So if we add one more nitrate, NO3-, okay, are we balanced out now? Yeah, because we got +2 charge, and then we got -1, -2. Okay, so how many total nitrates do we have? Yeah, we got 2. Because remember, these are molecules. They come as a package. They come together. Okay, so we have 2 total nitrates. So all we got to do is put a 2 in front of the NO3. Okay, so we have 2 of these guys. Okay. And then we're going to draw our arrow. And like we said, these two are going to combine, right? So we're going to combine Ca and we're going to combine that with NO3. Okay. How many CAs did we use? We used 1, right? There's no number. And how many NO3s did we use? 2. So we can't just put a 2 right here because that means we have 32 oxygens, which obviously we don't, right? So we're going to have to put the parentheses around the NO3, okay? So when you use multiple polyatomics, just make sure you put it in parentheses and put a, however many you use behind it. That's why we did the parentheses problem earlier. Okay. So again, it's not anything really different. It just looks a little bit scarier because we have a polyatomic ion, but it's literally the same thing that we did last time. Okay, so if you got it, should be pretty good. And if you're still figuring this out, then it's some good practice for y'all. Okay. All righty, you guys think you could try one on your own? Yeah. Okay, I'll give you guys about 3 minutes. You guys can work with the person next to you. I want you guys to try number 2 right here, Fr+, and you're combining that with sulfate. Sulfate's a pure polyatomic, so just make sure you look for that on your polyatomic chart, okay? Okay, so we start with Fr+, and we look for sulfate. So if you take a look on your polyatomic chart, you should be able to see sulfate is SO4 2-. So all we're going to do is just copy down sulfate right here on our problem. Okay, so sulfate is SO4 2-. Okay, and then we are combining that with Fr+. Okay, so if we take a look at this problem, do we have more positive energy or negative energy? Got more, oh, sorry, that's 2+, that's 2-, my fault. Yeah, it's more negative energy because it's 2- versus 2+. My bad, I made a mistake. Okay, so yeah, we got more negative energy because it's -2 versus +1. So that means we're going to need some more positive energy to balance that out, right? Yeah, we're going to add another FR. So how many FRs do we need in total? 2, exactly. So we can just put a 2 right here. If you like drawing it out on the bottom to kind of, visualize it, that's totally fine. I personally do that still. But what we're going to do is we're going to draw an arrow to combine it together. We got 2 FRs, so we're going to write FR2, and we combine that with SO4. And since we only needed 1, we don't need the parentheses, okay? So there you go. This is going to be your final answer right there. And I cannot draw a straight line. Okay. So what's inside of the box is what you should be able to provide, basically exactly like that, okay? All right, any questions? Hopefully it's not too bad. Yeah, it's, again, literally the same thing. Now we're just adding another chart onto it. Okay, so I'm going to go into the last type of problem. So if you guys remember last time, we learned how to draw the reaction with the starting materials, but then we also did the opposite, right? We can get the ending material, the product, and figure out what the starting materials are. So we'll go to that. So we'll skip number 3 right here. And then let's do this problem right here, okay? So we got this big, old, ugly molecule, and this is the product that we make. So this is what we are going to be making. So we got to figure out what it is made out of, okay? So if you guys take a look at this big, old, ugly molecule, anyone want to take a shot at what the first, or the cation is, the positive? Yeah, Chase. Yeah, it's ammonium, because you're going to see parentheses, right? NH4. And if you look at your polyatomic chart, you'll see that ammonium is NH4. So we know that our first cation is NH4+. Okay, good catch on that. NH4+. Okay. Now, how many total NH4+s are we using? Yeah, we need 3. So that means we needed 3 to make this molecule. So we can put 3 in the front. Yes. Sorry, multiply what? No, go ahead. I want to make sure that we're clear. Yeah, you mean like this, right? So yeah, you are correct. So if we were counting the elements, we would say, hey, there are 3 nitrogens and 12 hydrogens. That's kind of what you're referring to, right? Okay, so that is correct. But here we're trying to keep the polyatomics together. Remember, if you see any of these guys, you want to keep them in the same group because they like to stick together. Yeah, well, thank you for clarifying that. Okay. Yeah, so if you see a polyatomic, anything on this chart, you want to keep these guys together. Don't break up the polyatomics. The other stuff you can break apart, but the polyatomics you keep together. Yeah. Okay, and then we're going to combine that with the negative anion. Anyone want to take a shot at what the anion is? Yeah, Jose. Yeah, phosphate. If you notice, the only thing left over is PO4. So if you go right here, you'll see PO4 is phosphate. And PO4 is 3 minus. So PO4 is 3 minus. So PO4, 3 minus. There's no parentheses, so we only need one of it. And if you guys notice, if we do this, it balances each other out, right? You got 3 positives, and you got 1 3 minus. Yes. This number right here? Yeah. That tells us that there's 3 of these guys. That's why we put a 3 right here. Yeah. No, thanks for checking, guys. If you have questions, let me know. See you guys. Okay, and then for the product, the thing that we make, it's pretty easy. We just copy this down. We make NH4 3 PO4.
The majority of your students are in biomed. Please walk the class over to the auditorium. Otherwise, please send those biomed students to the auditorium on their own. Thank you and have a great day.
It's LPS, right? Yeah. Yeah, ours is today at 1 o'clock. So 5th period. Okay, so that's basically what you should get. Don't worry about it. 5th period. Expectations. Yeah. Alrighty, you guys think you could try one on your own? Okay, so if you guys take a look right here, I'll just give you guys a hint. For number 5, only one of them is a polyatomic. Okay, the other one, you got to figure out what the charge is. So this one, you got to find the polyatomic and then figure out the charge of the other one. Okay, so a little bit trickier, but I believe in you guys. So I'll give you guys about 3 minutes. Try breaking this one down, writing the equation, and after that, we'll go over it and I'll get you started on the assignment. Alrighty, guys. So if we take a look at this molecule right here, H2SO3, there's one polyatomic in there. What's the polyatomic? Yeah, sulfite. You're going to notice that there's SO3, and you're going to notice that there is SO3. So sulfite is SO3 2 minus. So what we can do is we can take out a sulfite out of this molecule right here. So SO3 2 minus. Okay. And then how many sulfites do we have? Yeah, just one. There's no parentheses or anything, so it means we just have one of them. Okay. Okay, and then we are combining it with the other thing. The only element we have is H. Okay, so it's H. And how many H's do we have inside this molecule? Yeah, we got 2 of them. Okay, so we don't know what the charge for H is, but we can figure it out. So if sulfite is -2, so H together needs to be +2. But since we have 2 H's, what do they individually need to be? Yeah, they got to be +1, right? Because they both need to be +1 to get +2, which balances out the sulfite right there. So that's another problem that you're going to see. You're going to have to figure out what the charge is based on the polyatomic. But just kind of, it's the same thing we did last time. Last time I told you the charge. This time you look up the polyatomic to see the charge, okay? So we got 2 total hydrogens, so we can put a 2 in the front. And then we're combining them together. And then so if you put them together, you make H2SO3. And there you go. This is your chemical reaction. Alrighty, guys. So I will give you the rest of the class period to work on your assignment. Just remember the paper that I gave to you, that's yours. I do not want it back. So just hold on to that. You'll need it for your upcoming assignments and for some stuff coming up. Make sure you don't lose it. But yeah, let me know if you have any questions. Yes.